Imagine an object so powerful that once you cross a certain boundary, there is no escape, not even for light. These mysterious objects are called black holes, and they're among the most fascinating and terrifying things in the universe. Black holes don't simply appear out of nowhere. They begin as enormous stars, living brilliant lives before ending in explosions so violent they reshape entire regions of space. Today, we're following the complete journey of a massive star, from its birth to its spectacular death, to discover how nature creates these cosmic monsters. The birth of a giant. Every black hole starts as a giant cloud of hydrogen and helium floating through space. Over millions of years, gravity slowly pulls the gas together. As the cloud becomes denser, pressure and temperature rise until the core reaches nearly 15 million degrees Celsius. At that point, nuclear fusion begins. Hydrogen atoms combine to form helium, releasing enormous amounts of energy. This energy pushes outward while gravity pulls inward, creating a perfect balance that allows the star to shine for millions of years. Our sun is doing exactly this right now, but not every star shares the sun's peaceful future. Stars that are more than 20 times the sun's mass burn much hotter and brighter. Because they consume fuel so quickly, they live only a few million years instead of billions. Their incredible brightness is actually a sign that they're racing toward an explosive ending. The star begins to die. Eventually, the hydrogen fuel in the star's core runs out. To survive, the star starts fusing heavier elements. First helium, then carbon, then oxygen, then silicon. Each stage happens faster than the one before. The final stages of the star's life may last only days. At the center, iron begins to build up, and that's where everything changes. Unlike lighter elements, iron cannot produce energy through fusion. Instead of supporting the star, it steals energy from the core. Without enough outward pressure to balance gravity, the core suddenly begins collapsing under its own enormous weight. This collapse happens incredibly fast. Less than a second, matter is compressed to densities almost impossible to imagine, while temperatures rise into the billions of degrees. The most powerful explosion. As the collapsing core reaches extreme density, it suddenly stops. The outer layers of the star crash into the solid core and rebound outward, creating a massive shock wave. The result is a supernova. For a brief moment, one exploding star can shine brighter than an entire galaxy containing billions of stars. The explosion sends enormous amounts of energy and radiation across space. It also scatters heavy elements, such as gold, silver, uranium, and many others into the universe. Those elements eventually become part of new stars, planets, and even living things. In fact, much of the material in your own body was forged inside stars that exploded billions of years ago. In a very real sense, we are made of stardust. When gravity wins, after the explosion, only the crushed core remains. If the core isn't extremely massive, it becomes a neutron star. A tiny object so dense that a single teaspoon of its material would weigh billions of tons on Earth. But if the remaining core is more than about 2 to 3 times the sun's mass, gravity becomes unstoppable. No known force in the universe can resist it. The core continues collapsing until it becomes so dense that the escape velocity exceeds the speed of light. That is the exact moment a black hole is born. Around it forms an invisible boundary called the event horizon. Anything crossing this boundary can never escape. Not spacecraft, not planets, not even light itself. A cosmic monster that never stops growing. Despite the name, a black hole isn't an empty hole. It's an incredible amount of mass compressed into an unbelievably small space. Black holes continue growing throughout their lives by pulling in nearby gas, dust, stars, and sometimes even other black holes. As material spirals inward, it forms a rapidly spinning disk called an accretion disk. Friction heats this material to millions of degrees, making it shine brilliantly. Ironically, some of the brightest objects in the universe exist because matter is falling into something completely black. Scientists also know that black holes can collide and merge, creating even larger black holes. These enormous collisions send ripples through space itself, known as gravitational waves, which were first detected on Earth in 2015. Today, astronomers believe nearly every large galaxy, including our Milky Way, contains a supermassive black hole at its center. Some contain billions of times the mass of our sun. Black holes may seem like terrifying monsters, but without them, And without the exploding stars that create them, the universe would look very different. The same violent deaths that produce black holes also create the heavy elements needed for planets, oceans, and life itself. Every piece of gold on Earth, every atom of iron in your blood exists because massive stars lived, died, and scattered their remains across the cosmos. So the next time you look up at the night sky, remember this: somewhere out there, a giant star may be living its final moments, and when its life finally ends, it won't simply disappear. It will unleash one of the most violent explosions in the universe and leave behind one of its greatest mysteries, a black hole.